Welcome to today's deep dive. We've got a really fascinating mission for you today.
We really do.
Yeah, because we're going to help you discover a completely free, totally offline, and community-driven way to navigate the world.
Right, essentially bypassing the massive tech giants entirely.
Exactly. Because, we're looking at a multi-billion-dollar piece of invisible infrastructure that you use every single day, right? But you probably don't actually own it. It's that blue navigation line on your phone.
Which most of us just blindly follow, without a second thought.
Totally. We just assume it's the only way.
Hmm?
But our guide for today's mission is an upcoming article, along with its official cover art, actually, for the Health, Science, and Technology podcast.
And specifically, we're looking at episode 3 of their 25-episode first season.
Right. Slated for release on Tuesday, June 23, 2026. And, the production metadata they shared with us really sets the tone for this whole discussion.
It really does.
Yeah.
It's produced by Djere Services Group. You can check them out at djere.com. But what immediately stands out is the creators' extreme, and I mean extreme, dedication to open source architecture.
Oh, absolutely. I was kind of geeking out over this. They didn't just use standard off-the-shelf software. They actually listed their entire tech stack for us.
Which is pretty rare.
Yeah, so they're running Pop! OS GNU Linux as their operating system. They used GIMP for image editing, Shotcut for video processing,
Wow.
and Zim Desktop Wiki for organizing all their notes. That is a full ecosystem of free software.
It is. The only proprietary tool they let into their workflow was NotebookLM.
Right, and that kind of ideological commitment, to controlling the hardware and software layer, it isn't just a quirky preference. It completely drives the premise of their article.
Exactly, because if you fundamentally believe that software should be transparent,
Right,
and user-controlled,
yeah,
you are eventually going to run into a wall when you have to actually navigate the physical world.
Yeah, because the default mapping tools most people use are, well, they're the exact opposite of transparent.
Totally. They're complete black boxes. And it's a fascinating shift, really, because when we rely solely on proprietary platforms, we just naturally assume the map is the territory.
Right.
But the moment you peek behind the curtain, you realize there is this massive, just an intense tug of war happening over who controls spatial data.
So true. And before we get into that whole software clash, I actually want to describe the cover art they provided because it perfectly captures this tension for you listening at home.
It's a great visual.
It really is.
Right.
So on the left side of the image, there's this green road bike, right, with a smartphone mounted to the handlebars, and it's just resting on this quiet, dirt, rural road.
Very peaceful.
Yeah. But as that road stretches toward the right side of the frame, the physical dirt sort of shatters and it digitally transforms into a high-tech, glowing green and blue map interface. Yeah, you see these server icons, glowing location pins, and little satellite dishes streaming data right down to the phone.
It's just a brilliant visual metaphor. I mean, it highlights the intersection of raw human exertion and the incredibly complex data networks required to track it.
Exactly. And the author's journey actually begins with that very physical exertion. They had a really relatable goal. Honestly, they just wanted to get fit.
Simple enough.
Right. So they committed to riding their road bike every single day. And naturally, they pull out their phone and check Waze and Google Maps to plan their routes.
Which is what anyone would do.
Sure. But the author notes that even as of late 2026, Waze still has absolutely zero support for bicycle navigation.
Zero. That's crazy.
Literally none. And Google Maps, it does have a biking mode, but they found it highly unsatisfactory for their specific fitness needs.
And this is where we really start to see the cracks in proprietary algorithms.
Yeah.
Because those systems, they're heavily optimized for vehicles and commercial commerce. They aren't built for a guy on a bike.
Okay, let's unpack this. Because using car-centric apps for a quiet bike ride, it's like using a sledgehammer to swat a fly. It's the wrong tool, and it might just ruin your day.
That's a great way to put it.
But I do have to push back a little here. I think a lot of people listening might wonder, if you're just riding locally for fitness, why do you even need an app at all? Like, why not just memorize a route in your neighborhood?
Well, it's really about the why. If it were just casual exploration, you'd be totally right.
Okay.
But the author is doing serious fitness tracking.
Okay.
And that requires navigating to highly granular, really hyper-specific landmarks to hit exact mileage goals.
I see.
Yeah, like if your training regimen dictates a 15.2-mile ride today, you need a turnaround point that perfectly matches that distance.
Right, and mainstream algorithms simply aren't weighted for that.
Precisely. If you look at how something like Google Maps calculates a route, It's using these graph traversal algorithms that weight nodes based on, high traffic roads, fast travel times, and commercial points of interest.
Like gas stations and fast food joints.
Exactly. It actively resists routing you to some random, obscure trail marker in the middle of the woods just so you can hit a 7.6-mile turnaround. The logic prioritizes getting a car to a business efficiently, not helping a cyclist achieve a precise biometric target.
That makes total sense. And considering our author is a 20-year advocate of free software, or FOSS as they call it, they absolutely refuse to compromise by using a closed system that ignores their needs anyway.
Right, they have strict principles.
So if the corporate tools fail, they need raw map data that they can actually control.
Which forces them to look for an alternative data set. And, that search points them to one of the most successful crowdsourced projects in internet history, OpenStreetMap, or OSM.
Yeah, and the origin story of OpenStreetMap is essentially a masterclass in data rebellion.
It really is.
The catalyst happened back in 2004, driven by this huge clash over public data ethics in the United Kingdom.
Right. So the UK has this national mapping agency that conducts what's called the Ordnance Survey. And it's an incredibly detailed, comprehensive map of the entire country. And crucially, it was funded by British taxpayers.
Wait, so the public paid for the collection of all this spatial data?
They did. But here's the catch. The government operated under a trading fund model.
What does that mean?
It meant the mapping agency was required to recover its own operating costs by essentially acting as a commercial business. So instead of releasing this taxpayer-funded data to the public under an open license.
Let me guess, they locked it down.
Exactly. They charged exorbitant licensing fees for anyone wanting to use the digital maps.
Which fundamentally means the taxpayers paid for the data to be gathered, but then had to pay again if they actually wanted to build software with it. That's wild.
Yeah, and a software developer and free software advocate named Steve Coast looked at that cost recovery model and found it completely ethically unjustifiable.
I don't blame him.
He believed observable facts about the physical world, like, the location of a road or the shape of a park, those cannot and should not be copyrighted by a state entity that the public already funds.
Right.
So in 2004, he founded OpenStreetMap to crowdsource a completely free map of the world.
Here's where it gets really interesting. Because, it's kind of like Wikipedia, but for physical geography.
That's a perfect comparison.
But I'm a little skeptical, honestly. How can a ragtag group of volunteers mapping, local trails and rail stations possibly compete with massive tech companies sending fleets of camera cars around the globe?
Well, if we connect this to the bigger picture, it's not just about drawing lines on a screen. It's a philosophical stance.
Okay.
It's the belief that publicly funded data about our shared physical world should belong to the public. So it's not just a polite request to share data, it's a structural attempt to legally inoculate geographic data against privatization.
So what are the specific protections he put in place? Because, software usually relies on the GNU General Public License, but data is trickier, isn't it?
Exactly. You can't copyright a fact, right?
Right.
But you can copyright a database of facts.
Right.
So OpenStreetMap operates under the Open Database License, or ODBL.
ODBL.
And it guarantees 3 explicit freedoms. Freedom 0 is the share freedom, which grants the absolute right to copy and distribute the database.
Okay, pretty standard.
Then freedom 1 is the create freedom, allowing you to produce new works directly from it. And freedom 2 is the adapt freedom, which is the right to modify, transform, and build upon the data.
Wow. And to protect those freedoms long-term, the OpenStreetMap Foundation was officially registered as a nonprofit on August 22, 2006.
Exactly.
But let's look at the mechanics of this for a second. Because how does a volunteer-driven database handle the inevitable vandalism or just conflicting edits? If it's truly open, couldn't anyone just go in and erase a highway or draw a fake bridge over a river?
You'd think so, but it's actually a highly sophisticated ecosystem. The system doesn't just accept raw edits blindly.
Oh, that's...
No, every single change is tracked in what's called a change set. And senior editors and automated tools monitor these change sets constantly.
Like Wikipedia editors.
Exactly. If an edit deletes a massive number of nodes at once, like someone trying to erase a major highway, the system flags it immediately, and automated rollback tools can revert the damage instantly.
That is fascinating. So the community is effectively peer-reviewing the physical world in real time.
Yes, and they even set up geographic bounding box alerts.
Bounding box alerts.
Yeah, so if a user tries to add a new road in a local neighborhood, The seasoned editors who specifically monitor that geographic bounding box get notified, and they go in and verify the edit.
That's incredible. But, having a pristine open source database of the world's coordinates doesn't actually solve the author's biking problem on its own.
Right, because of the connectivity issue.
Exactly. Because if you are out on a trail with no cell service, a database sitting on a server in London is totally useless. You need a software application layer to bridge that gap between the data and the user experience.
And the author's sources take us back to the early days of smartphones to explain how developers first tackled that exact connectivity problem.
Oh, this part is a massive nostalgia trip. So in 2008, the author bought their first smartphone, which is the very first Android phone ever released, the HTC Dream.
Oh, wow.
Yeah, the one with the big screen and the physical slide-out tactile keyboard.
A highly influential piece of hardware for sure. But as we know, the mobile networks in that era were, well, they were not what they are today.
Not even close. I mean, by 2011, mobile data was expensive, it was slow, and completely unreliable once you left dense urban areas.
Right.
If you were biking in a rural area, you had zero connection. So the author discovered an app called Navme, which was also sometimes known as Navfree.
And Navme was brilliant because it utilized the OpenStreetMap data, but it engineered a way for users to download massive portions of it directly to their device's local storage.
Like how massive?
Well, you could download an entire U.S. state like Missouri or an entire country like Turkey or Japan just right onto your phone.
Wait, I want to dig into the technical reality of this for a tech-savvy listener. Fitting an entire country's road network onto the tiny SD cards of a 2011 HTC Dream is not a trivial task.
Not at all.
I mean, if they were using standard raster image tiles, which are basically just millions of JPEG images of a map at different zoom levels, it would have been gigabytes of data. The phone would have choked.
You've hit on the exact technical breakthrough there. Because Navme wasn't downloading images, it was downloading vector map data.
Vector data.
Yeah. Instead of saving a picture of a road, vector mapping saves the mathematical coordinates of the road's start and end points. And then the phone's processor renders the line visually in real time.
So they basically compressed heavy geographic data into tiny binary XML formats.
Exactly. Vector data requires vastly less storage space. And crucially, it allows the routing algorithm to calculate directions directly on the device's CPU.
Because it already has the math.
Right. The phone doesn't need to ask a remote server for directions. It already holds the mathematical graph of the entire state locally.
Okay, but wait. If it's totally offline, how does it know where you are? Are GPS signals totally free?
Yeah, they are. The satellites are just constantly broadcasting.
Wow. Okay, so it's like carrying an entire encyclopedia in your backpack, so you don't need to find a Wi-Fi connection to search for a single fact when you're out in the woods.
That's a perfect analogy. And what's fascinating here is how this was just a massive technical workaround for the era. Navme empowered users to completely sever their reliance on expensive data plans while still utilizing dynamic turn-by-turn navigation.
It sounds amazing, but the author's story brings a pretty harsh reality check here.
It does.
Because recently, when they got back into serious daily biking and went to install Navme, well, the app was technically still listed in the store, but the servers were completely dead. The project is just a ghost town now.
And that perfectly illustrates the fragility of software ecosystems. The OpenStreetMap data itself, the raw coordinates, those are highly resilient because of the ODBL license we talked about.
Right.
But the proprietary or third-party software built on top of it, that requires continuous capital.
Because server hosting costs money.
Exactly. And updating an app to survive the constant churn of Android and iOS operating system updates, that takes thousands of developer hours. When the maintainers run out of time or money, the tool simply dies.
Which leaves our author staring at a broken app, needing a new way to track their daily mileage. But because the raw data survived, the community was able to just build a new interface.
Yes. And that new interface is the modern solution the author actually uses today. It's called Organic Maps.
Okay, Organic Maps, released in December 2020, right?
Correct. It's a fork, basically a derivative version of an older project called Maps.me. And it essentially acts as the spiritual successor to Navme.
Nice.
It takes the same core philosophy, full local offline vector map downloads, but it completely modernizes the execution. It features highly optimized routing modes for driving, walking, and crucially for the author, bicycling.
But what makes Organic Maps a game changer isn't just the offline routing. It integrates perfectly with the user's OpenStreetMap account. It transforms the app from a read-only map into a two-way street.
And this is where we see the author finally solving their granular fitness tracking problem.
Exactly. So let's say the author needs to turn around at exactly 7.6 miles to hit their daily goal. If they ride out to that exact spot and the physical trail marker or the bench isn't on the map.
They don't have to wait for a corporate camera car to drive by in 3 years?
Exactly. They just pull out Organic Maps, drop a pin at their exact GPS coordinate, and add the landmark to the database right then and there.
It's like walking through a forest and dropping a trail of breadcrumbs. But the moment you drop a breadcrumb, it instantly appears on the map of every other hiker in the entire world.
That is so cool.
The user literally becomes an active cartographer.
So what does this all mean? It's like laying down the train tracks while you're literally driving the train. You're building the map in real time as you ride your bike.
It really is. And thanks to those bounding box alerts and the change set peer reviews we talked about earlier, that new trail marker is vetted by the community. If it's accurate, it stays forever.
The author is literally building the map to satisfy their personal biking metrics. But, the ghost of Navme still hangs over this, doesn't it? Organic Maps is amazing today, but what prevents it from becoming dead software in 5 years?
Right. And this raises an important question, which brings us to the author's deeply pragmatic call to action. They understand the heavy burden of sustainability.
Because open source software is free to use, but it is astronomically expensive to run at a global scale.
Exactly. Which is why the author explicitly provides links to donate financially to both the OpenStreetMap Foundation and the Organic Maps developers.
Yeah, they state their hope that these projects survive a century, a full 100 years.
Which requires a radical shift in how we view technology. We're so conditioned to expect tech companies to, pivot, get acquired, or just shut down every 5 to 10 years. But the author is asking the community to treat this software as permanent digital public infrastructure. Really, no different than a physical national park or a municipal library.
But libraries require taxes, and parks require rangers. If we value our data privacy and we want routing algorithms that actually serve our specific needs, we have to voluntarily fund the upkeep.
And that is the underlying takeaway of the author's entire workflow. It is a powerful argument for digital agency. You do not have to accept the default closed-box solutions that came pre-installed on your hardware.
That's such a great point for you listening, whether you are prepping for a highly specific bike route or maybe traveling to a country with spotty cell service, or you just simply value your data privacy. There is a collaborative, community-built alternative that you can actually help build.
And as we consider the future of spatial data, I want to leave you with a technical scenario to mull over.
Okay, let's hear it.
Right now, this battle is happening on the flat screens of our phones. But in the very near future, augmented reality overlays are going to become mainstream. We will have digital information projected directly onto our field of vision as we walk down the street.
Right, like holographic navigation arrows painted on the sidewalk or digital reviews hovering over a restaurant.
Exactly. But augmented reality requires spatial anchors. It needs a highly precise, three-dimensional map to know exactly where to attach those digital holograms.
Okay.
So the question becomes, who controls the spatial anchors?
Oh, wow.
If a proprietary tech giant owns the map, they own the anchors, and they dictate exactly what you are and aren't allowed to see painted over your local park.
That's a little terrifying.
But if millions of volunteers continue to map the physical world through OpenStreetMap, those spatial anchors remain public.
Wow. If the spatial anchors are public, anyone can build an AR layer on top of reality. It means the map in your pocket today is actually the foundational infrastructure for the augmented reality of tomorrow.
The lines we draw today dictate the reality we see tomorrow.
That is incredibly powerful. The next time you pull out your phone to look at a map, remember that the invisible infrastructure doesn't have to be a black box. You have the power to step outside the default, protect your data, and maybe even drop a few breadcrumbs of your own. Thanks for joining us on this deep dive.